So let's continue with another example. This time we will be using a method of suction. But before that, let us assign letters from every joint, or in every joint rather, clockwise. So I'll start here from the roller. So I'll call this as A, and then this would be as B, and C, D, and E. And then the height of the truss is 12, and the whole length here is 24. So also, I'll just indicate here that the distance here towards here is 6, y by ratio and proportion. So let's call that to be y. So we're having y equal to 6. So let's prove that it's actually 6. So actually, if you're just familiar with ratio and proportion and you use all the time, then you would already convince yourself that it's 6. But let's just show that it should be 6. So ratio and proportion, so it's 12 over 24 equal to y over 12. So it's now equal to y equal to 12 times 12 over 24, and y is 12 times 12 over 24. It's 6. Alright, so anyway, let's just place it here. And our next objective, we're gonna solve for the values of the reaction. So we have here a hinge. So I'll be placing the vertical direction here as BV, and I'll have here BH as the left side, and I'll have here AH on the right side. So let's solve for the values of the reaction. Summation of forces vertical equal to 0. We will have BV upward minus 60 kips minus 70 kips equal to 0. So BV is equal to 130 kips. So this is the reaction for BV. So I'll just make it a little bit thicker. So here, and then summation of moment. I'd like to do the summation of moment at point A equal to 0. So we could solve for BH. So BH here, it's negative BH times 12, and then plus 60 times 12, and plus 70 times 24 equal to 0. Transposing this to the other side, it will become positive. So it's now BH equal to, so it's 60 times 12 plus 70 times 12 divided by 12. So what is the value of our BH? Let's compute. No, not 12. This is 24, sorry. That's 24. That's 60 times 12 plus 70 times 24 divided by 12. So that's equal to 200 kips. So is it really 200? So 60. Let's have this one. 60 times 12 plus 70 times 24 and divided by 12. Okay, that's 200. And let us continue. Summation of forces horizontal equal to 0. have BH equal to AH. These are the only two reaction, and I mean horizontal. So therefore AH is also 200 kips. And that's all for the bar forces. So I'd like to cut this out. Let's just move it there. So let's cut this out, and here. We will now be solving for the bar forces, and it should be in method of section. So I'd like to have the cutting section. So I'd like to have the cutting section here, and I'll consider the right portion. So what would be now the cutting section? So the cutting section would be this illustration. So that's the cutting section. So let's just transfer it here. And of course, we have members. This is for member. So let's have this one. This is for member. Member AE. So we have member AE. Then we have member AC, and this is for member. This is for member BC here. And then the angle of inclination from the horizontal. So let's get the angle of inclination. Let's use black and this one. And from here. So from the horizontal here, so what would be that angle? So from the illustration, this horizontal and this angle is, let's call this as theta. If this is theta together with this line and this horizontal line, it makes an angle theta as well. So since this triangle is also the same with this triangle, then this is also theta. So if this is theta from the horizontal, which is the same with the horizontal here, and with this line, which is the same with this line, somehow this is also theta. So we're gonna proceed in solving for theta. So what is the value of our theta? Theta can be computed as a tangent function of y, which is y equal to 6 over 12. So therefore theta is, let's use a calculator, arctangent function of 6 over 12. It's 26.57 degrees. So that is the value of our theta. Okay, so we now have theta. But what we're going to do here, let's just apply the angle here as theta and here as also theta. Let's get the components for every inclined loads, or every inclined load. We have here, we need to get the assumption first. Assumption. I'll have the assumption to be BC as tension and then AC as compression. So anyway, it's just an assumption. So if our assumption is wrong, then we have to correct it. So this is BC sine of theta, and this is BC cosine of theta. And for AC here, for AC we have AC sine of theta, and then this is AC cosine of theta. Right, how about for AE? I'd like to have AE as compression, so I'm gonna have AE as compression. So here, this is compression AE. Okay, so what we're gonna do here is we're gonna solve among the three members one at a time. So we need to solve for BC, AC, and AE. So there are three unknowns. So I'd like to have the summation of moment about point C. Why? Because if you try to let this BC pass through C, it's not going to create any moment. So it's going to be eliminated from the equation. Then also for AC, since this is AC, so it's still going to pass through point C. So it's going to be eliminated as well. The same way with this force 60, it's still going to pass, like this one. Oops, I did it again, like this. So this 60, it's actually just going to pass through C, so it's going to be eliminated. So therefore we only have AE and 70 to be rotating about point C. So it now eliminates the other members. So here, summation of moment at C, clockwise positive, counterclockwise negative. We'll have AE as counterclockwise, so that's negative times the value of Y, because that's the moment arm. Y is 6, and then plus 70, because 70 will rotate point C with a clockwise direction, times 12, and that's equal to 0. So therefore AE, transposing it to the other side, it will become 70 times 12 over 6. So AE is, let's solve AE, 70 times 12 over 6. That's 140. 140 kips, and the assumption is correct that it is compression. Okay, we're through with AE. The thing is, we don't have the values of AC and BC yet, so it's now easy to solve for them. So solving for them, we need the other equations of statics. So let's just copy this one. So let's copy this, like it here. Oops. Paste the image. This one. So we're gonna have the summation of forces vertical equal to 0, because we will be looking at the values of BC and AC in particular. So that's BC sine of theta. What is theta again? It's 26.57. 26.57, and then plus AC sine of 26.57, and then minus 60. then minus 70 equal to 0. So arranging it according to its order, so sine 26.57 then plus AC sine of 26.57, transposing these to the other side, it will become positive. 60 and 70 is 130. Equation number 1. Next is we're gonna have summation of forces horizontal equal to 0. So let's start with BC. So it's negative BC, it's to the left, cosine of 26.57, then plus AC cosine of 26.57, and plus AE. AE is 140. So it's 140 equal to 0. So transposing this to the other side, it will become, or just this one, except the coefficient, or constant rather. So it will become positive BC cosine of 26.57, and then minus AC cosine of 26.57, and that's equal to 140. Equation number 2. So with that, we will be using the method of elimination and substitution, but since we have a calculator that can solve or that can help with that equation, so might as well use the calculator. So we will be solving for the numbers BC and AC. So mode, and let's look for the two unknowns to equations here. So it's BC sine 26.57 sine, then AC, so AC is sine 26.57, that's equal to 130. Okay, second equation, cosine 26.57, and then negative cosine 26.57, and the constant is 140. So you will have BC here, BC, and that's equal to 223.59 kips, and we obtain a positive value. BC, our assumption for BC was tension. It's correct. Okay, so here, and then the next one is AC. The AC is 67.05 kips, and our assumption for AC is compression, so it's compression. Let's borrow this box anyway. Okay, so we have these forces, so let's do an update. So we're through with this, also this one, and this one. So what would be our next section to be used? So again, we will be using this. It's really all up to you if you're going to draw multiple diagrams of this one, but you can actually just supersede any colors or any section here, like this one, cutting through that. So it's really all up to you, but in my case, since I am showing you how to do it, so as much as possible I'd like the illustration to be cleaner. Okay, so let's proceed in considering another section. So I'd like to have a section that will cut through here and consider here. So with that, it's basically just going to give you a method of joint, as you can see here. So that section, so I'll just call this one as section, no, just change it. I'll call this as section CD, and this is for for CD, I'd like to have it in tension, and for DE as compression. And again, the angle here is theta. So theta is 26.57. Is it 26.57? Okay, so it's 26.57. So let's now get the components. The component for CD. So here, this is in tension. So CD sine of theta. And this one here as CD cosine of theta. So we can now solve for CD and DE by using the summation of forces vertical equal to 0. So you have CD sine of theta 26.57, then minus 70 equal to 0. Then CD is equal to, transposing 70 to the other side, it will become positive 70 over sine of 26.57. So CD now is, let's use our calculator. Let's go back to the mode math, and this is 70 over sine of 26.57. It's 156.5 kips, and our assumption as tension is correct because our value is positive. Next is we're gonna have the summation of forces horizontal equal to 0. So you have DE to the right minus CD cosine of 26.57 equal to 0. And transposing CD to the other side, it will become 156.5 positive cosine of 26.57. So DE now is, let's solve for DE. It's 156.5 cosine of 26.57. So that's 139.97. So that's 139.97, and this is in kips, and we obtain a positive value because our assumption DE to be compression is correct. And here we now have the two unknowns. So let's just update. So we're through here and also here. So what we're going to do now is we will be solving for this portion, this one and this. So with that, we can actually just cut. We will cut through the section. So I'll make another section. So I'll copy this one. So I'll copy this. And here, oops, paste the image. Okay, so since our objective is to solve for that, I will now be having a different section. So the section would pass through here. So this one. And by that, so let's just change the style. It should be that. So I'll consider this portion. So I'll consider this portion. Okay, so how do we consider that portion? So let us now cut and draw. Okay, so I'll just draw the section. So there's a vertical, and then there's an incline, and then there is the middle, there is another vertical. So it's not vertical, so vertical, another vertical, and a horizontal, and also here. So our objective is to solve for by the way, this is joint B, C, and D, and we have values of the reaction here as BV. BV is 130 and this one is 200. Is it 200? The reactions? Yes, 200 to the left. And we have members. This is member AB, and then this is member AC. Do we have AC already? Yes, we have AC, and our AC is compression. Then this is member CD, no, CE. Then this is member DE. DE is in what orientation? Compression. So DE is 139.97. AC is how much is AC? 67.05. This is 67.05. And then the angle of inclination from the horizontal of this AC. Okay, it's not working. So this is theta. So again, theta is 26.57. Right. So let's try to have an assumption. I'd like to have AB as tension, and then here as well CE as tension. So let's just check if our answers are correct or not. And then, by the way, the distances here, do not forget. It's really important to have this distances. So this is actually 24. So here. Okay, what happened to my illustration? So let's just delete this first, and then just make a vertical line, and then correct this. Okay, and then this one. Okay, this is 12 feet and 12 feet. And then here this is, okay, this is 12 feet here. This one. So this is 6 and 6. Okay, let's have summation of moment at, oh, do not forget, we have force here, that's equal to 70 kips. We have summation of moment, so let's just transfer this. Let's just transfer it here. Okay, let's do the summation of moment about point C equal to 0. It's about point C because we have two forces to be eliminated whenever not as a point C, and then we have also an incline force, so it's better to cancel that out. Okay, so summation of moment at point C, clockwise positive, counterclockwise negative. Yeah. So let's have the summation of moment at point C, we have AB counterclockwise, negative AB times 12, and then minus 200 times 6, and then plus 130 times 12, and plus 70 times 12, minus 139.97 times 6 equal to 0. Transposing AB to the other side, we will have AB equal to, copy everything, that's going to be negative 200 times 6 plus 130 times 12 plus 70 times 12 minus 139.97 times 6, and this is divided by 12. AB is equal to, it's negative 200 times 6 plus 130 times 12 plus 70 times 12 minus 139.97 times 6 divided by 12. So it's 30.015. So it's 30.02 kips. And we obtain a positive value because it is correct. So our assumption is correct that it is tension. Okay, now we're gonna proceed in solving for C, summation of forces vertical equal to 0. So you have positive 130 minus AB, and then the component vertical, that's positive 67.05 sine of 26.57 as theta, and then minus 70 equal to 0. So is it correct? So do we have 1, 2, 3, 4, and CE. So we need a CE. We don't have the CE yet. Minus CE. 1, 2, 3, 4. 1, 2, 3, 4 terms. 5 terms. Okay. Equal to 0, and transposing this to the other side. So it will become positive, and that's equal to 130 minus AB, which is 30.02, plus 67.05 sine of 26.57, and then minus 70. So our CE value is, let's get our calculator. So that's 130 minus 30.02, then plus 67.05 sine of 26.57, and then minus 70. So the answer is 59.97. 59.97 kips are in our assumption. We obtain a positive value. So this must be in tension. So there. So we now solved the last portion of the section. So this one and that. So let's proceed in writing the table. So we have here, remember, and then there are 1, 2, 3, 4, 5, 6, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, 7 members. So we have 7 members. Okay, so So this must be for AB, and then AC, and then BC, and then CD, then CE, and then DE, and what's next? So you have CE, D, AC, AC. After AC, it's going to be AE. So it's AE here. Okay, next is you have the force, and the force is in Kip's course. Next is the stress. You know already what to label for stress. Okay, and let's proceed in doing the table. So you have to really present your analysis as clean, neat as possible. So actually, there are already templates naman ready. So you can use the AutoCAD and other softwares. So this is just a manual in how to do the structural analysis. So let's write AB. AB is 30.02, and it is in tension. CE is 59.97, and that is in tension. Then CD is 156.5, CD 156.5, and that is in tension. And then the DE, no, DE is 139.97. So it's 139.97, and it's in compression. For AC, it's 67.05 compression. 67.05, and its compression. ABC is 223.59. 223.59, and it is in tension. And AE is 140 compression. Okay, that's it. This is your structural analysis.